and, oh my God, I've literally forgotten the word. I thought content. That's not the word.
No.
Commentary.
This is a Particle Podcast. WA Science told different. Powered by SciTech.
Good evening, everybody. My name is Leon.
And I'm Beth.
And welcome to Please Look Up, your monthly deep dive into space news.
And commentary.
Recorded at SciTech on Whadjuk Noongar land. Thanks for being here, Beth.
Thank you for having me, Leon. So, what's up this month?
What's up this month? Excellent question, as always, Beth. Well, remember how the last couple of months we've been talking about the parade of planets?
Planets.
Yep, it's been marching across the sky. Mm-hmm. It's well and truly over by now.
Oh. They're gone. No planets ever again.
They're not completely gone. But, last month where we mentioned you could, in the early evening, see all of the 7 planets in the sky plus Earth beneath your feet.
Yep.
This month, if you're going outside without a telescope at night, you'll only be able to see 2 planets, which is Mars and Jupiter.
Okay.
Now, Uranus and Neptune are still there, like they were last month, but
yeah.
I did specify without a telescope.
Yeah.
You can't see them. But then the other 3 planets, Mercury, Venus and Saturn, have disappeared from the night sky.
Right, because they were, those were the 3 that were close to the western horizon, so I'm guessing they've just continued on their meander westward.
That's exactly right, and so this month they're lost in the glare of the sun, actually. Yep. Saturn's going behind the sun, Mercury's going in front of it, Venus is going in front of it, I meant to say. And they will reappear in the late month, right at the end of the month, in the eastern sky in the morning before sunrise. But
the other side.
Yes,
the
other side.
The opposite of what they were last month.
Yes, but also 12 hours later.
Yep.
So it's not that they've moved that far, it's just that the Earth has done another half turn.
We have gone the opposite, really.
Yes, that's right. It's not the most obvious thing when you first think about it. One day it's there in the western evening sky, and suddenly it's there in the eastern morning sky, and you're like, but what happened? It's like you also have to remember it's 12 hours later.
Yes.
Yeah. But you're actually better off just waiting till April if you want to go see them, because when I say they're out at the end of the month, they're not that good. Just wait a couple more days. Yeah.
But what we can see quite clearly, if my amateur stargazing over the weekend says anything, Jupiter and Mars are still putting on quite a show, I think.
Still putting on a show in the northern sky.
Okay, so we're turning right.
We're turning right. Again, we're violating our months-long starting point of always turning left.
Yeah.
No, we're making like the US and turning to the right. So that was, I had to do that.
So we've turned to the right.
And we're facing north. And
we have our lovely sort of reference point of Orion.
Yep.
Particularly easy constellation to spot. And then Orion will lead us quite nicely to Taurus, and Jupiter, in a similar position to where it was last month, is still hanging around Taurus's horns.
Yep. Yeah, it's relatively speaking barely moved. So can't miss it.
Yeah, it's really, really obvious. It's very big and very bright.
And then, sort of more towards the northeast, you have the reddish spot of Mars. And it is next to the 2 bright stars of Gemini, the 2 twins, Castor and Pollux, which we spoke about.
Yeah, we spoke about a couple of
recently. Ago. And again, relatively speaking, it hasn't really moved. So you'll have this sort of triangle of bright objects in the northeastern sky, and the one at the top is the red one, Mars.
So that's pretty much it for planets this month?
That's your planets this month, yeah. But it does lead us to a nice reference point. Mm-hmm. Now that we've found our planets in the north, we're going to turn around and face to the south.
Okay.
Because there's some interesting stars that I want to talk about.
Oh, stars in the south?
Yes.
We haven't looked at stars in the south in ages.
Yes. So I guess we'll start, as we always do in the south, by finding the Southern Cross, which if you've turned around and are now facing south, it's towards the southeast, so kind of the lower left. It's not exactly bang on south, but during March it's in the sort of the southeast on the left-hand side of the sky. But really, I want you to look up quite high.
Okay.
Quite high in the sky, and you should find a very, very bright star, sort of, just high up in the southern sky. Not to be confused with Sirius, the brightest star in the sky, which is in the north, but it's not too far from there because it's the second brightest star in the sky. And we have spoken about this star before.
Canopus?
It is Canopus, yes.
Yeah, part of Carina.
Carina.
Which is just a lovely word. I just enjoy saying that word.
I know people called Carina.
Yeah, it's a beautiful word. But it's not by itself.
No, it's part of a trio of constellations which make up a boat.
Yes.
And so Carina is the bow of the ship. So, the strong part of a boat.
Yes.
Maybe I guess anyone called Carina can take that as a compliment.
Yeah. And then Vela is the sail,
Yes.
and then Puppis is the poop deck.
Yes, the back of the ship.
Nothing to do with poop, it's to do with Dutch.
Yes, that's right, which
Yeah.
I think just means back, is that right?
Yeah, I think so.
Yeah, we say stern. I think
Yeah,
Dutch is
yeah.
poop or puppis. Yeah,
Yeah.
there you go. This trio of constellations, we could spend ages and ages and ages describing it. But
Yeah.
long story short, just imagine a boat that starts in sort of the middle south and then stretches all the way quite high up in the sky. And, you can bust out Stellarium on your phone if you want to. It's a huge constellation. It's a huge part of the sky. But even if you can't be bothered looking at it with your app on your phone, you can definitely spot Carina. It's so obvious.
Yeah, it's very, very bright. So the Argo Navis trio, I think we have actually mentioned before, but I think it was a while ago.
It was.
So the Argo was the ship that Jason and the Argonauts, called so because of the boat,
Yep.
It was the ship that they took on their voyage for the Golden Fleece.
Yes.
Now, I found out something fun today, which was when that story was first being told, we're talking ancient Greek here, the constellation of the Argo Navis would have been more visible in the northern hemisphere in certain Mediterranean latitudes than it would today. So, if you think about it, it would have looked like it was sailing on the river of the Milky Way.
Of course.
So
there you go.
Yeah. So the Argo Navis looks like it's sailing on the Milky Way.
Funny, we will come back to that in just a moment.
Oh.
Once I tell you my fun fact about the Argo.
What's your
the
fun
Argo.
fact about the Argo Navis?
Oh, just that we mentioned the constellation of Gemini before in the north where Mars is, and two of the sailors on board the Argonauts were Castor and Pollux.
Oh, there we go.
Two of the sailors on board Argo, I should say.
Yes.
But I mean, they pop up in all the Greek stories. They were at the Battle of Troy, for example. I think I mentioned that last month.
Yeah.
So they just pop up everywhere. But I thought that was pretty cool.
That is pretty cool. I really enjoy how lots and lots of the stories and the constellations are interlinked, and also sometimes how even when they're almost used generically sometimes. So it's like, we need two people for this story. We'll use those two. Okay. Yeah. Even though it's like, these people are now thousands of years old if you go by the actual timelines.
Yeah, exactly. No, I found when I started writing the Sky Tonight articles for the SciTech website, I used to get lost in micro details of the mythology.
Yeah.
And then after a while I realised it all just kind of blurs together. So now I just
enough,
sort of take very general stories and write about those.
Well, if you tell the same story for 2,000 years, quite a lot of the time it changes a little bit.
Yeah. So just pick the one that's nice and easy to tell but still gets across the main points.
Yeah.
So
what's this thing about the Milky Way that we're going to get back to?
Well, it's to do with what you said, that thousands of years ago the Argo Navis might have been easier to see from the northern hemisphere, and that brings us to the equinox. Of all things. So the equinox happens once a year. It's when the sun passes. Twice a year.
Twice a year.
When the sun passes directly over the equator, and it marks the astronomical transition from summer to autumn, and it's where we have equal amounts of day and night all over the Earth.
So 12 hours everywhere.
More or less, yeah. There's some fancy regions that ever so slightly vary. Doesn't matter.
And then there's a valley in Norway, which
things like
is
that,
entirely in shadow.
Assuming the Earth was a perfect sphere, you would get 12 hours. Yeah. And then, if you're at the equator, you'll see the sun pass directly overhead on the day of the equinox, which is pretty cool. That's
pretty cool.
On March the 20th, I believe.
Okay, so 20th of March is the official astronomical, in the southern hemisphere, turning from summer to autumn. And then I guess in the northern hemisphere, that means it's the turning of winter to spring.
Yes, that's exactly right. Because they're opposite in the opposite hemispheres. But the physical interpretation is still the same. Sun passes over the equator. The thing is that, remember in last month's episode or the month before, and I'm not going to explain it now either.
Together.
But they all blur together. I mentioned that you mentioned that I'd had a note saying talk about Milankovitch cycles, and I said the Earth wobbles on its orbit, and then I just moved on, and I am just going to move on. But one thing that does happen as the Earth wobbles around is that the day of the equinox actually drifts very slowly by about 1 or 2 days per century.
That's very unhelpful.
Yeah. However, what that means is over the time, the Earth's north and south pole point to slightly different spots, and it's called the precession of the equinoxes. And over thousands of years, different parts of the sky are visible more easily to different places on Earth.
Oh, okay.
So yeah, it's entirely plausible that 5,000-6,000 years ago in ancient Greece or whatever,
The Argo Navis.
The Argo Navis, which is a very southerly constellation, was actually a little bit more northerly many thousands of years ago because of the precession of the Equinox, which is a Milankovitch cycle. But again, we'll, for now, we've just learnt a word, but the concept of the Earth wobbling is really what is the important thing here.
Okay, I need to note to self to Deep Sky Dictionary the Milankovitch cycle.
We might do that.
Milankovitch cycle?
Yeah, we'll put that as a Deep Sky Dictionary for next month because they're fun, but they're not something you should just gloss over. You need to give them the proper love and attention they deserve.
Okay, all right. So we'll get back to the Milankovitch cycle. But
yeah.
for the moment, Argo Navis, pretty obvious in the southern sky.
Yeah, and the Equinox.
And the Equinox.
Which is very cool.
Yeah.
But I want to ask you, Beth, because we touched on Jupiter being in the sky, in the northern sky before. It's been up there for a while. It's time we gave it some proper attention with star stories.
Star stories.
I'm a star! A great big shining star!
About Jupiter. So we've continuing in our little series of discussing the planets and a little bit of the star stories behind the planets. So, Jupiter, king of the gods.
And I think most people know just a little bit about
Most people probably know a little bit about Jupiter. Also, the sky and thunder god. What's also quite fun about Jupiter is that he's very concerned with oaths.
Okay.
So, and like oaths and duty. So by Jove, as an exclamation, is known as an oath, and actually Jove is Jupiter. They are the same person.
Yes.
Which is ironic, really, that Jupiter is so bound by oaths, because his own oath of marriage to, I would note, his twin sister, Jupiter's opinion of his own marriage doesn't appear to be the same standard of oath-keeping that we would in most modern contexts.
Got a bit of a reputation, doesn't he?
Yeah. Which I think is perfectly illustrated by the myth of Minerva, his daughter. Now, Minerva is the Roman equivalent of Athena, and the stories are pretty similar. So
just to clarify before we do that, so Jupiter is the Roman version of the Greek god Zeus.
Yes,
Which many people have heard of, and Juno is the Roman wife of Jupiter.
Yes.
And what's the Greek equivalent of Juno?
Hera,
that's
yes.
right. And then Athena is Greek and Minerva
and Minerva is Roman.
Yeah, because that was kind of mentioned, just to fill in the backstory. I can see you're eager to get on with the story, Beth. But yes, the Roman names are just copies of Greek religions, but the names are mostly Roman.
Yeah. So a lot of the stories carry across, and they've just sort of, pasted a new face on them. So yes, Jupiter married to Juno. However, Jupiter's daughter Minerva, her mother was Metis, the Titan, not Juno, Jupiter's wife.
Right.
This is just one of a pattern of behaviour that we can expect from Jupiter. Now, there's like we were talking about, myths, thousands of years, there's debate as to how consensual the conception of Minerva was, but it ends up with Metis, pregnant, turning into a fly to try and hide from Jupiter, because Jupiter was afraid that his child would kill him like he killed his own father.
Yes.
So obviously to solve this problem, Metis was a shapeshifter, turned into a fly because Jupiter tricked her into turning into a fly. And Jupiter then ate her.
I've heard about this. I heard he ate Metis. I didn't realise it as a fly.
Yes. So he ate her, and then inside Jupiter's body, Metis gave birth to Minerva.
What is this story?
Yeah, it gets better. And forged weapons and armour within Jupiter, which gave him a really big headache.
Oh my goodness.
So Jupiter's son Vulcan split his head open with a hammer, and out popped Minerva, a fully armour-wearing adult.
That's a pretty metal birth story.
Yes. Now, Metis, Jupiter's not wife, is the name of one of the innermost moons
Yes,
of Jupiter.
I am aware of that.
And this is where we get to the point where, and I think we have mentioned this before, that all of Jupiter's moons are named after his extramarital affairs.
Yes. So we're talking about the astronomy Jupiter now, the planet.
Yes,
and all of its
Jupiter, the
moons.
planet, all of the planet Jupiter's moons are named after the extramarital affair partners of Jupiter, which is quite impressive when you take into account just how many moons Jupiter has.
Yeah, we're up to 95 now that we know of around Jupiter. To be fair, not all of them have names yet.
No,
They're just called like Jupiter XX1 or something like that.
Yes.
But yeah, a lot of the ones
that have names
yes,
are all named
are
after.
Yeah.
Which is especially funny to me because when NASA decided we're going to send up a probe to investigate Jupiter's moons, what did they call it, Leon?
Of course, it's called Juno.
It's called Juno. NASA sent up Jupiter's wife to check on him and his ladies.
Mm-hmm.
I just think it's very fun.
Yeah, it's interesting. And I guess this also comes back to what I mentioned before of micro diving onto details about stories.
Yeah.
The thing with Jupiter is there are so many stories.
So many stories.
And it's quite sort of circular back and forth in the sense that ancient people looking at the sky would have noticed that this absolutely monstrous object up there, which we now know to be the planet Jupiter,
Yeah.
It clearly wasn't the moon, and it
Yeah.
behaved differently to Venus. Venus was always close to the sun,
Yeah.
whereas this other independent king of the sky
Yeah.
understandably became the king of many religions.
Yeah, absolutely. And then also if you're talking about like constellations and planets and just using the sky as a big storybook,
Yeah.
it's it's very easy to tell stories about the big obvious one that's there most nights.
Yes, that's right. and then, yeah, as those stories became more and more evolved and adapted, we ended up with Jupiter having hundreds and hundreds of lovers.
Yeah, absolutely, because it's like, let's pick a convenient god that we've heard of to make this story about.
Yep.
And also, it does lead to some interesting things where, like, Jupiter is the god of, he's very concerned with oaths, but I know that Hare is the goddess of marriage. So there's all sorts of fun mythology about how I think that the Greek story that leads on from the birth of Athena, so this equivalent of Minerva, is that basically Hera sees that Jupiter has just popped a baby fully formed out of his forehead and has gone, well, I can do that too, and she promptly gives birth to Hephaestus all by herself.
Of course.
Yeah.
Yeah. Parthenogenesis applies to gods as well.
Yeah, gods, revenge, it's all sorts of fun, but I just enjoy that these ancient stories can keep us looking up at the sky.
Yeah. Wow, thanks for that deep dive into just one of the many, many stories about Jupiter.
It's so much fun because it involves so many other things in the sky.
It does. Speaking of other things in the sky, when you're out looking at Jupiter this month, as we say, it's inside the constellation of Taurus, and then you look up above Taurus and you see...
Okay, so we're looking north.
Yeah, we're looking back to the north now.
Back in the north.
Yep.
Okay.
You look
I
up.
found Jupiter, very shiny. There's Taurus, the little V.
Yes.
What else am I looking for?
And then we keep craning our neck high in the sky. We're looking higher this month.
We're going up. Okay, we're going up.
And you see Orion, the 3 stars.
Yep.
And then you keep looking up.
Oh, my goodness.
And we're looking above Orion.
Okay.
Just above the top 2 stars that make Orion's, well, in our case, knees, because he's upside down in our sky. There is another constellation there.
Ah, yes.
Kind of has 2 little bright stars and other ones nearby. It's not hard to spot. It's hard to make a pattern out of, but somebody else has already done that for you.
Yeah.
And that is Lepus.
Lepus?
Yeah, I call it Lepus. You've been saying Lepus all day.
I don't know if that's just because of leprosy, though.
I don't know, maybe you can tell us. But this is our constellation of the month.
Constellation of the month. Orion.
You're not going to sign that one, are you, Beth?
What?
You're not going to do your own?
Oh, just constellation of the month?
Yeah.
I don't know. You said it first, though, so I feel like you have to do the...
Oh, no. There's
okay.
quicker ways of dying than listening to me sing.
Constellation of the month.
Perfect. Lepus, which is a hare.
Yes.
In case you're wondering.
A bunny.
No,
technically not.
Yeah, I was
They
going to
are
say
two
hares
different
and
things.
rabbits, not quite the same. So yeah, this is a pattern of stars. It's not too hard to see the stars actually out of the many constellations up there that are very faint and very hard to see. This is actually quite easy to
nothing
see.
like a rabbit, though.
But yeah, you've got to kind of again look at it on a star chart to actually understand the pattern that the star chart makers are going for
It
there.
looks like an H.
It does look like an H.
An H for hair.
That's it. You've cracked it.
Cracked it.
You
Lepus
go.
is good fun. So, like the Argo Navis, it's actually one of Ptolemy's 48 constellations. So it's one
This
that's
is a very old one.
been around for a very long time. I think Ptolemy's constellations was 2nd century.
I think you're right. Yeah, it was a long time ago.
Yeah, so a couple thousand years old. And again, you've got lots of interesting names going on for different stars within this constellation. So Alpha Leporis, its common name is Arneb, which means hare in Arabic. But, weirdly, that's not the ancient Arabic name for that star.
Right. Oh, so it's been retrofitted to...
Yes. Yeah, so it's a bit of an odd one. So Lepus or Lepus is known as the hare that Orion is hunting.
Yes.
So Orion and his hunting dogs chasing after this hare, although I think if they're chasing it, they're not very good at their job because he's literally like standing on it. And
Yeah,
they
he is too.
caught it.
Yeah.
Yeah.
Right.
Anyway.
Anyway.
And it looks like he's fighting Taurus, so he's not doing a very good job of
He's
catching
pretty
this hare.
busy, you know.
Yeah. So the Arabic for this particular group of stars, so there's sort of the 4 brightest stars in Lepus in Arabic are actually called like the throne of the giant.
Really?
So referring to Orion.
Oh, I
and
see.
then there's another one which is called like the back of the throne of the giant.
Oh,
And
okay.
then I can't remember what the other one was called, but the last one, which is Nihal, which is Beta
So the second brightest
Leporis,
star.
so the
Yep.
second brightest star, is known as camels quenching their thirst.
Of course it is.
Yeah,
Yeah. Why
all
not?
of the others are to do with this chair of the giant, which makes sense because
Yep.
it's like the giant Orion is sitting on it,
and he's
and
on
then
it, yeah.
and then there's also some camels there having a drink.
Yeah.
Yep.
Why not?
Yep. And so Nihal means quenching their thirst.
Oh, there you go.
Yeah.
That's really fascinating.
Yeah.
Yeah, and that's the thing, that stars take all sorts of unusual names depending on who's named them and
Yeah.
what the history of that is.
Yeah, and which came first? Because I got confused and I ended up down a rabbit hole
Hey.
because
well done.
I was trying to work out what was going on with these stars. That I was like, what do you mean it's called Hare in Arabic? Because it's not called. That's not what the Arabic. What?
Yeah.
So yeah.
Ah, there you go.
So the ancient Arab name for the star is not Arneb at all.
It's,
but
yeah, it's camel drinking.
yeah.
There you go. The interesting thing about Lepus from sort of the astronomical point of view is that within Lepus, if you point a telescope, there's a globular cluster located inside the boundaries of this constellation. So a globular cluster is a very, very dense concentration of maybe a couple of 100,000 stars, but packed way, way tighter than the average star density of the Milky Way.
Okay.
And they actually orbit around the Milky Way. And we still don't really know where they come from.
Wait, do you mean it orbits around the Milky Way? So, like, a globular cluster isn't part of the Milky Way; it's outside of it.
It's outside of the Milky Way,
Okay.
yeah. But it's not large enough to be a galaxy. Like we talk about the Magellanic Clouds and things
Yes.
like that. The leading hypothesis on globular clusters is that they are the cause of other small galaxies that the Milky Way has eaten.
Oh.
But that's still being actively researched as we speak.
But they're pretty.
Yeah, they are. So they look like they're very spherical.
Mm-hmm.
What's interesting about them though is there's about 135, about 150 globular clusters that orbit the Milky Way. Almost all of them are close to the middle of the Milky Way. As
Okay.
they're in the direction of sort of Sagittarius,
Right.
which is exactly on the opposite side of the sky to Orion and Lepus and things like that. So this globular
what's this
cluster,
one doing?
yeah, they're not really sure. There's one idea that the Milky Way is in the process of eating another galaxy called the Canis Major Dwarf Galaxy.
Okay.
The problem is that we're still not quite sure if the Canis Major Dwarf Galaxy is even real.
What?
Yeah,
Surely, if our Milky Way is eating it, then we would know that it exists.
it's hard to say because it's right in line with the Milky Way.
Oh,
And
so like we're eating it side on rather than
yeah,
like,
from our
top
line
down.
of sight.
Yeah.
So there's a slight
So there's a Milky Way in the
over
way.
density of stars. That's all they see when they see the average number of stars, and then in this direction there's slightly above average number in the direction of Canis Major.
Okay.
And so the leading idea is that maybe this globular cluster in Lepus once belonged to that other galaxy, and now as the Milky Way eats that galaxy, we've absorbed this globular cluster. It's called Messier 79, by the way, if you want to read more about it.
Well, I actually have another astronomical thing about the constellation of the month this month. Because there's not, out of all of our massive mythological connections, Lepus doesn't really have many. It's just a rabbit.
Yeah, I found that unusual too, that
Yeah.
Orion and his dogs hunted a hare one day.
Yeah, sometimes it is vaguely associated with the moon rabbit. The
rabbit.
if you look at the moon, it kind of looks like there's a rabbit outline.
Yeah, out of the dark parts.
Yep.
Yep.
But again, all I could find on that was that sentence.
Yeah.
Like, it's associated. I'm like, great.
Cool.
So I found another thing. So our Lepus is a kind of star. It's a star in Lepus.
So R, as in the letter
R.
R.
Yes, R.
Lepus.
Lepus.
So it's a very faint one if it's got a letter
Yes.
R associated to
Yeah.
it. Yep.
It is a kind of star known as a mirror variable. Now, this particular mirror variable is known as Hind's Crimson Star.
Ooh,
and my
goodness.
brain went, Hind? Isn't hind a weird word for a kind of animal? It's not. I'm not thinking hind and hare, am I? Is that why it's called? No. A hind is a deer.
Right.
It's called Hind's Crimson Star after John Russell Hind.
Gotcha. Yeah, I
Yeah.
was going to say that makes more sense.
Yeah. That was another rabbit hole that I ended up down today.
So, what is a mirror variable star?
So a mirror variable star, say that 3 times fast, is... So the variable part of the name comes from the fact that it is pulsating. So we see it brighter and dimmer.
Right, so its brightness goes up and down, so you might see it one day and not the next.
Yes.
But then the following day it's back.
Yes.
Yep.
The mirror comes from what's known as the prototype star. So the first star that we identified that did this pulsing in this way
Yes.
was called Mirror. So now the whole class is known as mirror variables because they all are variable in the same way
Right.
that Mirror is.
Yeah.
And Mirror is, it means beautiful.
Yes, it does, doesn't it? Mirror is in the constellation of Cetus, by the way, which we
Yes.
spoke about in December's episode of this podcast.
Yeah,
so
there
if
you
you want to
go.
hear about it, December 2024, Beth
Mirror's
and I talking about, I can't even remember if we spoke about Mirror, but we definitely spoke about its constellation.
Yeah. So why and what kind of star are these variable stars? They're actually late stage red giants.
Right.
So that means that they're going to go on and become planetary nebulae and white dwarf stars.
Right.
So eventually, this are Lepus?
Yeah, I can't remember.
One of them.
Yep.
So eventually its outer layers, so it is currently a red giant.
Yep, it's all held together. Yep.
And eventually its outer layers will drift off and become planetary nebulae when its core will become a white dwarf star.
Right. That's over the next millions and millions of years.
Yeah.
So for right now, it's sort of contracting and expanding and getting brighter and darker as it does that.
Yes.
Yeah,
and
so
I
that's-
think that mirror variables actually have a 100-year pulse as well.
Oh, okay.
Yeah.
Oh, interesting. So it's clearly something very traumatic is going on with the star.
Oh yeah, something is going on there.
Yeah.
Because our sun doesn't flash.
No, not like that.
No.
There's a few ways in which stars can pulse like that. One of the most basic models is that the outer layers of a star, right out the edge, the gas can cool down, and as it cools down, it forms, some very basic molecules, and those molecules absorb the light that is now shining from the star.
Okay.
So the star gets darker, but eventually they absorb so much light that they get so
Blasts
hot.
them off.
Yeah, that they ionize again, and then suddenly the star is transparent again, and then it cools down and blocks the light, heats up, and cools down and heats up, and so that's sort of a very basic model. If you're thinking like, how can a star pulse like that?
Yeah.
That's a very basic idea of how it can happen.
Oh, cool. Well, that's awesome. That's pretty much all I've got on Lepus, the little
likewise.
rabbit.
Yeah.
All
What a good choice for constellation of the month,
There
Beth.
you go. Leon, I'm pretty sure you chose it.
No. All right, it's time for our new, it's time to move on to our increasingly popular section. The Space Question of the Month.
Space question of the month. I want harmonies. Space question of the month. Space question of the month.
Oh, okay. We're just,
No?
the producer's shaking his head.
Oh. Space question of the month. What's the space question of the month this month, Leon?
So we've had Caitlin write in this month.
Oh.
And Caitlin's asked a question which I don't think is entirely coincidental with what's going on in the news at the moment, which is, if there was an asteroid that was going to hit Earth, is there anything we could do to stop it?
Oh, thank you, Caitlin.
Yes.
Great question.
Good question, Caitlin. And the answer is maybe, with a question mark.
I mean, I think the first answer is, how big is the asteroid?
That is 100% the answer. The answer is depends how big it is.
Yeah.
And I suppose the reason, as I suspect this is not a coincidence, is that in the news lately you might have heard about an asteroid that astronomers have discovered recently that has a small chance of colliding with Earth in the early 2030s.
Oh.
And yeah, it's a bit of a worrying thing. And in particular, this asteroid that they're talking about is anywhere from 40 to 100 meters across.
Right.
It's actually quite hard to tell how big it is.
I think the thing is the first thing that people associate with when you hear asteroid impact is the mass extinction of the dinosaurs.
Yes, that's sort of however, the good news is that the mass extinction of the dinosaurs asteroid event was, I think it was estimated to be between 15 to 25 kilometres across.
Okay.
So we're talking 1,000 times smaller, or,
Right.
500 times smaller. So the good news is that this asteroid that is in the news at the moment, we can do something about it.
Right.
Whereas if you spot a 25-kilometre asteroid with our name on it, we're kind of,
we better find a really big laser really quickly.
Yeah, you might want to drill down a deep core and put some bacteria in there to reseed the Earth in 2 billion years.
Oh, I was going to say, don't just, draw down on all your stocks or something.
No, we need to summon Bruce Willis.
Oh, okay.
Yeah. So what we can do, because this has been tested, is you can actually just fly a big old hunk of metal, a spaceship, as fast as you can and just smash into it head on, and you won't destroy it, but you will rob it of enough momentum to slow it down enough. And all you need to do is slow it down by just a couple of meters per second.
Really?
And in the time that it takes for that asteroid, the further away you can do this, the better.
Yep.
So if you can do this a couple of years before, you don't have to slow it down even as much.
We've got till 2032 or something.
Yeah, that's right.
Got ages.
Yeah. So that's the idea, is to just slow it down. So, because if you think about it, an impact means the Earth and the asteroid are in the same spot at the same time.
Yes.
If you can slow the asteroid down, so the asteroid arrives late and the Earth has moved out of the way by then.
We'll just be out of the way.
Yeah, and Earth moves across its size in, I think it's every 12 minutes. So you need to delay the asteroid by about 12 minutes, and then you're golden. So obviously if you...
Unless we do it precisely too far, where we delay it by exactly a year.
So that's the sort of general gist. And the reason we know this works is because in 2022, NASA conducted this exact experiment by flying a mission called DART, which stands for Dual Asteroid or Double Asteroid Redirect Test. True. And they smashed into an asteroid actually larger than the one we're talking about.
Oh.
And they slowed it down way more than anyone was expecting.
Oh.
It's very cleverly designed. It was a 150-meter asteroid orbiting a 500-meter asteroid. It's like a little moon.
Okay.
And what they did, the way they were able to measure it so carefully, is that they measure how long it takes the little asteroid to go around the big one.
Yeah.
And the time that takes obviously depends on how fast the little asteroid's moving. Mm-hmm. So then what they do is they smash the asteroid with our hunk of metal.
Oh, they smash the little asteroid.
Yeah, they measure how long it takes.
Oh, and it took longer.
Yeah. Oh, well, actually it took less because they slowed it down so it fell closer to the big asteroid and then picked up speed. But you can still work backwards and figure out how much you've slowed it down in the first place. And the effect was way more than they were expecting. They were expecting a 5% variation. They got a 30% variation on the speed. It was amazing.
Wow.
So yes, you can, as a matter of fact, for an asteroid of this size, just go out and punch it, and that will slow it down enough.
How do you stop an asteroid from colliding with Earth? Hit it with a hammer.
Yeah. And it doesn't have to be a nuke, by the way. That's the other thing. Because the other thing is, let's just blow it up with a nuke.
I just want it to be a laser, though, Leon. I just want to blast it to pieces with a laser beam.
I mean, those are some other ideas, that if you had centuries of warning, you could just shine a laser at it for long enough, because lasers carry energy and momentum. Yeah. And over centuries, you could just slightly push it off course. This is definitely not the only idea, but this is one that we know works.
I don't mean like a sensible science laser. I don't mean we shine a laser at it and it'll... I mean... Pew! Space laser.
like a terawatt,
Yeah.
petawatt laser.
Yeah, I want to explode it with a laser.
Now, there is something interesting that I want to mention about
Leon is not having any of this.
No.
Moving on immediately.
about this, because the thing about the way asteroid probabilities are calculated, when this asteroid 2024YR4 was discovered, it had about a 1.5% chance of hitting the Earth in 2032, which is actually quite high.
Oh.
And then what you do is you try and narrow down, so you take more and more measurements of the asteroid.
When you've got an asteroid that you're like, ooh, maybe we should keep an eye on that one.
Yeah, what you want to do is you want to refine its orbit so you can get a better idea of where it's going to be. And what actually happens is that the probability that you're going to have an impact actually goes up, and so it actually got up to about almost 3.5% chance of hitting the Earth.
Oh no!
But
That's
the reason for
fairly
that
likely
is it's very counterintuitive. But think about this: imagine you're trying to. You can see an asteroid now, and you're trying to predict where it will be in the future. Now, the problem is, unless you know exactly where the asteroid is now and exactly where it's moving,
right?
You can't know exactly where it's going to be. You
Yeah.
can kind of know roughly where it is, but you've got error bars on your measurement,
Yeah.
and those error bars propagate. And so,
Yeah, and when we're talking about sizes in space, that error bar could be the difference between it might hit Earth or it might hit Jupiter.
yes. And here's the funny thing is that when you propagate into the future, those error bars, they become a region of space where the
Yeah.
asteroid might be. And if Earth is inside that region, then you can calculate, Earth occupies 1.5% of that region.
Right.
Therefore, it's
There's
got a
a
1.5%.
1.5% chance. Okay.
Now, the thing is, as you get better and better measurements of your asteroid, those error bars get smaller, so your region gets smaller.
So Earth
But
will be
Earth
occupying
occupying
more of
more of
the
it.
region
Yes.
relatively.
Speaking,
Yeah.
that's right.
Okay.
But then eventually what happens is your error bars get so small that you narrow this region down so much that Earth is no longer inside the region.
Okay.
And the probability goes down to zero straight away.
Okay. That makes sense.
So yeah, this is always this alarming thing with asteroid hitting Earth predictions is the probability goes up and up and up and up and up and then drops to zero. And that's that error bar getting smaller and smaller and smaller with more and more measurements.
Fun.
Yeah.
What's that error bar at the moment?
It dropped this morning
Oh.
to 0.02%.
That's way better than
Yeah.
3%.
It's not zero though. So there are actually plans to use the James Webb Space Telescope to take some observations of it in a couple of weeks.
I thought you were going to say there's plans to use the James Webb Space Telescope to slow it down. I was like, no, not James Webb. We need it for the photos.
Worst case scenario, in case you're wondering, by the way, suppose it does hit Earth, how much damage can an asteroid like that do?
Yeah.
It's a city destroyer, basically. So yeah, you do not want to be in its path.
No.
But it's not going to erase life on Earth.
Okay.
But it's not good news.
Well, I thought that the thing about the dinosaur asteroid as well, though, was it wasn't like the asteroid crashed into Earth, because I think a lot of people's perception of that is that the asteroid crashed into Earth and hit all of the dinosaurs, which is why.
Oh,
But
yeah.
like that's not. Apparently the thing that actually caused the most extinction was, and it is still due to the asteroid, but that impact sparked a lot of geological activity and caused like a lot of volcanic activity, which caused massive ash clouds, which covered the sun and basically caused a lot of stuff to die.
Yeah, I'm certainly not a paleontologist or a geologist.
Yeah.
But yeah, my understanding is that there is a lot of debate about that whether it was volcanism that was also concurrent at the same time.
Yeah.
And yeah, the large-scale climate change was really actually probably the problem.
Yeah.
Not that an asteroid that big is good news either.
No, but yeah.
But it wasn't as simple as
it wasn't just that
overnight.
all of the dinosaurs were in a 250 kilometre area
Oh,
that
right.
was hit by the
Do people think that?
Well, I don't know. It's what I used to think when I was a kid.
Wow. Okay, there you go. No, I never
Because they
thought
told
like
me
that.
an asteroid hit the Earth and it wiped out the dinosaurs. I
Yeah.
was like, an asteroid hit the Earth and it wiped out the dinosaurs. I thought the dinosaurs got hit by the asteroid.
True. I mean,
And
every
also in
single
most
depiction
media, yeah,
shows a Tyrannosaurus Rex looking up.
yeah, and
It's an
or
asteroid.
being hit by a chunk.
Oh yeah.
Is in a lot of media
I
as
see
well.
what you mean. Yeah,
Yeah.
like secondary fall. Yeah. No.
No.
Worth mentioning. What's this podcast named after?
Please look up
Yes, it's
is
named
a-
after the Don't Look Up.
a movie that I've definitely seen.
The Netflix movie Don't Look Up, where everyone
don't
dies
tell-
in a
Don't tell Leon.
mass extinction event. big asteroid goes boom, everyone dies.
Hmm.
So yeah, it seems appropriate for us to talk about it.
Yeah, but unlikely to actually happen.
No, the chance is getting smaller by the day, which, as I said, is usually what happens.
Okay, That's good. Well, thank you, Caitlin,
Yes, good question, Caitlin.
for sending that in. And yeah, anyone else who would like to send us one of your burning questions, let us know. We are at ParticleWA on Instagram.
Yes, that's exactly right. At Particle WA. Tag us. Slide into our DMs. We'll get them. It's time for Spaceflight Focus.
2, 1. We have a liftoff.
Spaceflight Focus.
Perfect. Beautiful,
Yeah.
Beth.
You're welcome.
So, what's happening in space this month, Beth?
I don't know, Leon. I haven't written any notes on anything. No, I know a little bit. So, we've gone to the moon.
Yes, we're going back to the moon again.
Back to the moon again. Now, I remember, I think it might have been in our first revamped new format episode that we ever did.
Yes.
We spoke about a space fail, which was a little lander which got to the moon and then fell over.
That's right. I went back and checked that episode, yes. March
Yeah.
2024.
Yeah, so nearly a year ago.
Yes, in fact, exactly a year
exactly
ago.
a year ago.
Yeah.
Oh my goodness.
It's
So
moon landing time again.
It's moon landing March.
Do moon
That's
landings
what we-
always happen in March?
No?
Ah,
I think the moon landing was in July, was it not?
yeah.
Yeah, the famous one. But yeah, so a year ago, there was a little lander that tried, and it fell over.
And it fell over.
But its little sibling's going up. Its little sister. It's
Yes.
yeah.
So yeah, the background information is that there is a spacecraft called the Firefly Blue Ghost.
Firefly Blue Ghost.
Yes.
Okay.
So Firefly is an American aerospace company, and then they've got this spacecraft called the Blue Ghost, and it is on its way to the moon. In fact, it's already at the moon. It's orbiting the moon right now. It launched on the 15th of February, and it's going to attempt to land on the moon early March. 2nd of March at the moment is the current prediction, but that could change. But most likely 2nd of March, which is Sunday afternoon Perth time, about 3 o'clock in the afternoon. So
That's a very convenient time of it to try and do that.
it is, isn't it?
Normally, space stuff happens at an inconvenient time.
Yeah.
It's like, have you tried getting up at 4 a.m. to see cool rocket launches?
Yeah, I've definitely done that. And the reason for that actually is because at that time is exactly the sunrise on the moon in the location that they're landing. They want to land at sunrise.
Yeah, so that they can have a full
lunar day.
Lunar day.
Yeah. And yes, this is the third in what's called the CLIPS program.
CLIPS is a ridiculous acronym.
Yeah. It's actually just CLPS.
Yeah.
Stands for Commercial Lunar Payload Services.
So this is
I guess the keyword is payload, commercial lunar payload. So NASA doesn't build the spaceship or the rocket. They just pay money to other companies to build a spaceship and figure out how to get it to where they want it to go.
right.
And then on board is all of the NASA science equipment.
Right.
So so Firefly built this spacecraft called the Blue Ghost, and they actually build rockets too, but it actually launched on a different rocket. It launched on a SpaceX rocket.
Yeah.
And then on board are all of the NASA science experiments.
Right.
So NASA pays to rent space on that spaceship.
Right.
And so last year we had the Asteroid was the first attempt.
Yeah.
That one had an engine leak and burnt up in Earth's atmosphere.
Yeah.
And then there was Integrated Machines. That one landed on the moon,
Yep.
broke its leg and fell over. And so those are the companies, Asteroid and Integrated Machines. And then now we've got Firefly. They're having their turn.
Okay. But that's the third of CLIPS.
Yes, that's right. And CLIPS
Okay.
has, I think there's 7 or 8 different companies that are eventually going to be involved in this.
Yeah, because this is where it's a little weird because some people are saying it's so-and-so's second, it's so-and-so's third, and it's all of these different mini space programs, and you have to tell whether it's if it's the second moon lander in the CLIPS program or if it's
right.
and it just,
Yeah. So no, it's the third attempt from CLIPS, and it's Firefly's first.
Yeah.
And yes, so it's got a bunch of sort of very interesting science experiments on board, actually, which is the whole point of this, is to do some science.
Doesn't it have a probe? Or am I getting mixed up with a different lunar lander?
You might be getting confused with the Japanese one.
Probably.
Because it launched at the same time. In fact, on the same rocket was a Japanese lunar mission.
They really like to make my life specifically difficult, don't they?
Yes.
Okay, what's going on the Firefly Blue Ghost lunar, the Firefly Blue Ghost CLIPS lunar lander?
Good question. I thought you'd never ask. So it's got a bunch of really interesting science experiments. One is it's actually going to be testing how to get lunar dust off stuff. Because one of the biggest problems the Apollo astronauts had was the dust just got everywhere.
Yeah.
And if you're thinking of living on the moon, where this stuff possibly behaves like asbestos because it's very sharp and gets everywhere, then you need a way of getting it off your clothes. And so they're going to be testing, like, can you use electromagnetic fields to, like, fling it off your
Like
suit?
reverse powder coating.
Yeah, reverse powder coating, essentially. They're also testing, like, computers because, on the moon you're more exposed to space radiation. So, can we shield a computer well enough to last in the environment?
Okay.
They're actually going to try and take images of the sun from the surface of the moon, which is pretty cool.
Yeah, that's pretty awesome, because I guess that would mean that you don't have atmosphere in the way, but you have the stability of a lander rather than a spacecraft.
Yeah, exactly.
Yeah.
They want to study also during the sunrise and the sunset, how the sunlight passes through, what dust is in the moon's atmosphere, things like that. And they're also going to be testing, like, navigation on the moon, because here on Earth we have GPS and variations on that. But yeah,
No satellites around the moon?
Yeah, no GPS satellites around the moon.
Fun.
And so, they're going to be trying all these different things. And the whole point of being is, of course, to learn more for when people go there.
Yeah.
And that's the whole point of CLIPS, is to study and collect data before sending people there. And this is the next one in that step.
Oh, that's
Or
awesome.
it's rather the next step in that voyage, I should say.
I don't know what I had a look at, because I thought that there was a probe going up which was looking for something to do with water.
Funny you should mention. Remember how we mentioned the Intuitive Machines one that broke its leg and fell over?
Yeah.
They're launching a second one
That would
soon.
Okay, this
That's
is the
one
one that I'm thinking of then. Okay. So Intuitive Machines had a second one, which is called...
IM2, Intuitive
I
Machines
thought there
2.
was one called Athena.
In fact, that's probably it. I can't remember. Yeah, Intuitive Machines 1, I think, was called Odysseus.
Yeah,
and so, this one must be a
okay.
thing.
That's where I went. I was like, there was one. I swear that there was a lander which was happening soon.
Yes.
And it's something to do with clips. I just found the
Yeah,
wrong. I
that is
found
the
the
next
wrong
clips
clip.
one.
Okay, right.
Yeah.
There we go.
And the reason is that they say they're going to launch late February, but their dates are way less certain than... as I said, Blue Ghost is already at the moon. Whereas Intuitive Machines hasn't launched yet. So it may be launching in tomorrow.
It's late February now.
But
at time of recording.
Yeah, the fact that I was reading about them just the other day and they hadn't published a launch date tells me it's not going to be tomorrow.
Yeah, no.
But it will be soon, and we might be talking about this in the April episode of The Sky Tonight.
More clips.
More clips. And yes, so the Blue Ghost is going to be landing on the sort of near side of the moon in one of the dark craters.
Okay.
If we spoke about the rabbit you can see on the moon before. If you look at, you might need to get a picture of the moon. If you can see the rabbit, and then in front of the rabbit's nose, there's another crater. Looks like someone's about to bonk the rabbit on the nose with a tennis ball. That's the crater that Blue Ghost is landing in.
Okay.
Whereas the Intuitive Machines Athena, if that's its name, is going to be landing on the south pole of the moon.
Oh.
And looking for water, because that's the sort of thing. That's where they probably will eventually land astronauts, is down there, because they think there's a pretty good chance there's water there.
Yeah.
And water's just one of many, many difficult problems to solve on the moon.
Yeah.
So if it's already there, you've solved that problem.
Oh, that's good.
But that's what that's going to be looking at.
Okay, so spaceflight, there's actually clips.
Yeah, CLIPS is all over it. And as I said, there was a Japanese spacecraft on board as well that is on its way to the moon too.
Okay.
I don't know as much
JAXA?
about... this is a private Japanese company as well,
okay.
called... the spacecraft is called Hakuto R, and they're potentially going to be attempting a landing in April, but I really don't know much about that one.
Okay, so at the moment it's just staying on the spaceship?
It's in orbit either around the Earth or around the moon.
Okay.
I'm not actually quite sure where that one's up to.
Okay.
But we'll let you know next month.
Yeah.
So that's Spaceflight Focus this month. Keep your eyes on it if you see another moon mission, because it's worth mentioning that Intuitive Machines lander that fell over and broke its leg last year was the first US robotic landing on the moon in decades.
Yeah.
And so this might be the second. So, there you go.
That's historical.
Yeah. To be fair, as I mentioned, there have been other countries that have landed on the moon since then. We're kind of going US centric here, but so there's
NASA makes it very easy to be US centric.
That's right.
They are.
They're a lot more accessible.
They're very good at sharing their data.
So there we go.
I think that's pretty much it for
I
this
think
month.
that's everything. Well, I've had a time and a half, Beth.
Me too, Leon.
Thanks for being here.
Thank you for having me.
And thanks for listening, everybody. We'll see you next month when we talk about the night sky and the space news for April.
If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information. The constellation of the month this month.
Well, I have another astronaut.
Sorry. We scolded the producer last time that happened.